Good afternoon, students. So today we are entering into 12th practical session. So first experiment we are going to do about Ohm's law. So in this experiment, the main aim of the experiment is we are going to find the unknown resistance of a given wire. So for this we are going to use the principle called Ohm's law. So what are all the apparatus required for this Ohm's law? We can check it right now. So this is called as a battery, so which will be providing you the energy to the given components. The next one is key, which is going to provide you the connection between the battery as well as the circuit. So it's a connector or connecting switch, we can say like that. Then the next component is rheostat. So rheostat, or we can say this as variable resistance. So we can vary accordingly. You can able to see we can change the resistance over here. By moving this knob, we can vary the resistance. Okay, and then this is an unknown resistance wire which we are going to measure the resistance. So in this part we are going to measure the unknown resistance of this given wire. After that, for measuring purpose, we are going to use two meters. One is voltmeter, which will be measuring the voltage which is passing across this resistance wire, and then the current flowing through this wire can be measured by using an ammeter. So here you can able to see there was some readings over here. So it starts from 0 and then it goes up to 3. So this range of the ammeter is 0 to 3 amperes. So this particular ammeter can measure from 0 ampere to 3 amperes, and you can able to see that first one is 0. After that the big reading is 0.5. Okay, in between that there are 10 divisions. So least count of each division is 0.05. Okay, so the least count of the first subdivision is 0.05. Likewise it will increase accordingly. So likewise this pointer where it is pointing out, that will be the current reading. Fine children. So the next one is voltmeter, and here this voltmeter is also, it can measure from 0 volt to 3 volt. So here also you can able to see there are 10 divisions in between two main readings. The first one is 0, the next one is 0.5. So in between there are 10 divisions. So you can divide that 0.5 divided by 10, that provides you the least count, that is the first reading. And the mother code order reading and the least count vachi nama measure pannalam. Likewise we can improvise and we can measure up to 3 volt. Okay, so these are all the apparatus required for the given Ohm's law circuit. And then you can take down your circuit diagram. So this is the circuit diagram of the given Ohm's law circuit. So here you can see that battery positive is connected to ammeter positive. Then ammeter negative is connected to rheostat. Then battery negative is connected to key. From key, the other end of the key is connected to unknown resistance wire. In that end itself, voltmeter was also connected, and then voltmeter positive is connected to other end of the unknown resistance wire. Then from there the connection goes to rheostat. So that is what we are going to do in this circuit. So according to the circuit diagram, first one is battery positive. So here you can see there are two wires or two colors will be there. Red color indicates positive, black color indicates negative. Okay, so this is the battery positive. We are connecting a wire in the positive. You can able to see. So the positive of the battery is connected to, you can able to see here there is a wire, we have taken that and it was connected to ammeter positive. Battery positive is connected to ammeter positive. So ammeter also it will be having two colors. Red indicates positive, black indicates negative. So battery positive was connected to ammeter positive. Then from ammeter negative was taken to the unknown resistance wire, where we are going to measure the resistance. To that one end we will be connecting this ammeter negative. So ammeter negative was taken to the unknown resistance wire end. From there we can, from the same end we can take another wire which will be connected to the voltmeter positive, which will be connected to the voltmeter positive. You can able to see here positive, it will be red in color. So from this resistance knob we are going to take another wire and it will be connected to voltmeter positive. Then voltmeter negative will be connected to the other end of the unknown resistance block, So voltmeter negative will be connected to the other end of the unknown resistance block. From this end we will be connecting the wire to the rheostat. It will be connected to the rheostat. Here there will be a knob, you can connect it over here. In rheostat there will be two ends. Top end it will be here, and then lower end. So we can, if you are connecting it here, then the other connection must be at the top. Okay children, so here unknown resistance wire, from there it is connected to the lower end of the rheostat, Then to the other connection we will be going to the other side of the rheostat, it will be at the top end. So this top end of the rheostat will be connected to the key. So this will be connected to the key. Then key other end, the other end of the key will be connected to the negative of the battery. As per our circuit diagram, the connections were done. You can able to see the whole connections over here. So before connecting, you please check whether the wire ends are rusted or not. If it is rusted, please cut it and then use proper wires, and please check out the connections whether it is tightly connected or not. And then please check out whether the pointers are showing 0 when there is no current flow. So these are all the errors which will be often done in this experiment. So you have to be very careful while you are choosing the experiment. So wires as well as the meter pointer connections, you have to check it. You can able to see. So this is the general connection of the experiment Ohm's law. As you all know that voltage is directly proportional to current, that is according to Ohms. The potential difference across two ends of a current carrying conductor. We are going to pass a potential difference to the two ends of the current carrying conductor, and we are going to measure how much current is flowing in this wire, and we are going to measure that through a meter. So according to Ohm's law, the potential difference across two ends of a current carrying conductor is directly proportional to the current flowing through the conductor at constant temperature. So you can able to see that V will be directly proportional to I only when there is constant temperature. If the temperature varies, then there will be a new term called resistance will be entering into the circuit. So we are going to measure that resistance by using this Ohm's law. Hope you can understand, children. So this is the connection. Now after this, you have to take an 80 pages notebook and you have to write the observation. So in this order, that is experiment number, then title of the experiment, that is Ohm's law. Then you have to write what is the aim, apparatus required, procedure. Then to the left side of the observation, you have to draw your circuit diagram. Left side of your observation, you have to draw your circuit diagram. Below the circuit diagram, you have to draw the tabulation column where we are going to do the experiments and enter the readings. After that, you have to draw the graph. You have to paste a graph in this observation also. You have to write the observation along with the record. Both has to be written, children. The record copy will be given in the office. You can come and you can take printout of it and you can start to write. Back side of the graph, you can write the calculations. Calculation parts can be written at the back side of the graph. Then the continuation of the procedure, precaution, finally result. So this is the procedure to write an observation. So what the reading you will be taking in the observation, that must be entered in the record too. So it's very important, you have to write observation, it is compulsory. Now we can do the experiment. So for this we will be having a constant voltage, a potential will be chosen. Then we will be varying the rheostat and then we will be measuring what is the voltmeter reading and what is the ammeter reading. Fine. Now we can do it. We are switching on the battery. You can able to see here in the battery there will be an on button. If you are switching on, then it will glow. Okay, after switching on, you have to select the voltage. You have to select the voltage over here. So here I am setting 4 volt. Setting 4 volt. So in initially battery, we have to switch it on and we have to set the battery to 4 volt. Okay. After this, please check whether the voltmeter and ammeter is responding to the given battery. Please check it. Please check whether the voltmeter and the ammeter is responding to the given voltage. If there is any fluctuations, if the pointer is moving, then the ammeter and voltmeter is working. If it is not moving, then you have to change the ammeter and voltmeter accordingly. Okay. Now, how we are going to do this? So here, what we are going to do this, I am going to move this resistance, variable resistance. I am going to vary the resistance here. According to the resistance varied, the voltmeter as well as the ammeter will deflect. Okay, so likewise we are going to do this experiment repeatedly and we are going to calculate what was the resistance of this unknown wire. So how this will be done is, I am going to move the rheostat. I'm going to move the rheostat. You can able to see, I'm just moving this. I'm just moving this a little. Okay. So for this resistance, there will be a change in the voltmeter. You can able to see here. Initially, it was a 3. Initially, it is a 3. I am providing a resistance to that so that voltage got decreased. Can you able to see? So here now it is 2. Now it is 2. So initially, you can able to see. Initially, it was 3. Initially, it was 3. After providing a resistance, it is decreasing. Okay. So likewise we are going to, so each and every potential difference will cause a change in the current. You can able to see how much current is varying here. So I am going to vary the resistance. The rheostat, it is going to move. So I am moving that. You can able to see. The current is varying accordingly. So when the voltage is rising, there will be a considerable rise in current, but it will not be directly proportional. When the voltage is rising, here you can able to see that it is, I am varying the rheostat, you can able to see here the voltmeter is showing the volt called 2. So it is 2 volt. It is 2 volt. In voltmeter you can able to see here, after the movement of the rheostat it gone to 2 volt, and the corresponding ammeter reading is nearly 0.5. Nearly it is 0.5. If I am varying this again, you can able to see now it is 2.25, and there will be, now it is 2.25, the voltmeter after rheostat movement, now it is 2.25, and the corresponding ammeter reading, it improvises to 0.5. Previously it was less than 0.5, now it is 0.5. So you can able to see that when the voltage is increasing, the current is also increasing, but it is not rising linearly because of the component called resistance. So the resistance will decrease the amount of current. So because of the resistance, instead of getting 2.25 amps current, we are receiving only 0.5 amps. That is mainly because of this resistance. So how much the resistance value is, that is our aim to check out in this experiment. Likewise, for each and every reading, we have to check what is the voltmeter reading, ammeter reading, then it has to be plotted in the graph. So that's all for Ohm's law. Now we can go how the calculation parts is done and how the readings are done. So here you can see the first one is voltmeter reading. So initially I have set it to 0.5 volt. The corresponding ammeter reading, voltmeter reading is 0.5 volt. For this 0.5 volt, the corresponding ammeter reading is 0.1. Likewise, the experiment is repeated for different values, which means I will be varying the rheostat. First, I will set the voltmeter to 0.5 volt. After that, again I will move the rheostat, and then I will set the voltmeter to 2 volt. Likewise, the experiment will be repeated for 6 readings. So you can able to see here 0.5, 2, 2.5. Likewise, the experiment reading will be increasing or decreasing, whatever the orders you can have it. Okay. After that, the corresponding ammeter reading was taken here. For 0.5, it is 0.1. For 2, it is 0.4. For 2.5, it is 0.5. Likewise, the corresponding ammeter reading will be also measured through that ammeter. After that, we have to calculate what was the resistance of the given reading. So we all know there was a formula called V is equals to I into R. From that, we are going to measure what is the resistance. So what is the resistance? So resistance formula is R is equals to V divided by I. So for the first reading, the voltmeter ranges is 0.5 and the current reading is 0.1. So V divided by I. According to that formula, the resistance what you have received is 5 ohm. Similar to this, we have to do for all the other voltage and current readings. After that, we have to take average of all the resistance value. If you are taking average of that particular reading will provide you the unknown resistance. So this is the calculation procedure of the given experiment, Ohm's law. Calculation procedure. Then you have to plot graph for this experiment. So in this graph, you can able to see x-axis. It's very important, children. So x-axis we have to choose current. Y-axis you have to choose voltage. If you want, you can reverse it also, no issues. But please go according to this order itself. X-axis it is current, y-axis it is voltage. Okay. and then you have to plot what was the reading for each and everything. So 0.5 volt. For 0.5 volt, the current is 0.1. So I hope you know how to mark a graph. How to mark a graph? You know that x-axis 1 centimeter how many units and 2 centimeter how many units. You know that. I hope you can understand. So here you can see the scale. So x-axis 1 centimeter 0.1 unit. Y-axis 1 centimeter 0.5 unit. So according to the readings you can take the scale. According to the readings you can take the scale. Then you have to plot it. So for 0.5 volt. For 0.5 volt, the corresponding current reading is 0.1. So these two are connecting over here. Therefore, we are putting a cross mark over there. Likewise, each and every reading has to be plotted or it has to be cross marked. Then you can draw a line on it. So you can able to receive a linear graph. So this is the procedure to draw the graph for Ohm's law. Then finally you have to write the result. So here you can able to see that the value of unknown resistance is what is the value you have received. That particular reading has to be written over here. After getting average of 5 readings. Sometimes someone might receive 5, 4.8, 4.8, 4.6. Likewise, you might receive different values. So if you are averaging all those readings, what is the final reading you are receiving? That has to be written in this result column. Okay, children. So this is the first experiment of your class 12 practical Ohm's law. I'll repeat it. Ohm's law, we are going to measure an unknown resistance for the given wire. So it is working under the principle called Ohm's law, that is the potential difference across 2 points of a current carrying conductor is directly proportional to the current flowing through the conductor at constant temperature. So in this particular experiment, they might ask you the viva questions as why voltmeter is connected parallel, why ammeter is connected in series, and then what are all the components which is required for the circuit connection, what is Ohm's law, what is the formula for Ohm's law, and whether all the elements will obey Ohm's law. Such kind of questions might be asked as your viva. Okay, in your lab manual, the viva questions was given there. You can go through all those questions. So here we have determined the unknown resistance of the given wire. So the connections, after that you have to switch it on. Then you have to set the voltage to 4. Then you have to vary the rheostat. When the rheostat is varying, you will be getting a variation in your voltmeter. Correspondingly, there will be a variation in your ammeter. You can able to see here, I am going to vary this rheostat. If I am varying the rheostat, the current or the voltage, it will be rising. See, for each and every rheostat movement, there will be a change in voltmeter and ammeter. So the voltmeter will be varying, and then correspondingly the ammeter will be also varying. So for each and every voltage, what is the current you are measuring, you have to tabulate it. After that you have to use Ohm's law formula and you have to calculate what was the resistance value. Then you have to average all the resistance value. That will be your final unknown resistance of the given wire. So with this, your first experiment is over. Thank you, children.